This video is going to look at some examples of the chain rule, so we'll just jump right into it here. So in the first example here, if we have h of x equals 1 over 3x squared plus 1 quantity squared, the question is, what is the derivative of h of x? Well, if we look at this, this is very similar to the function f of g of x if f of x is equal to 1 over x squared and g of x is equal to 3x squared plus 1. In other words, you can see that we've got sort of this outer function of 1 over something squared and then an inner function of 3x squared plus 1. So our derivative here will be the derivative of that outer piece, which is the derivative of 1 over x squared. So that will be 1 over, let me rewrite this in a way that we can maybe see it in a different way if you prefer. 3x squared plus 1 to the negative second. I don't need that extra bracket there. So we'll do the derivative of the outer part first. I guess I need that so they're equal. Derivative of the outer part means we pull our derivative or our exponent out front, and then we subtract 1 from it. And that'll give us negative 3. And then we also have the derivative of everything inside here, which is 3x squared plus 1, which is going to be equal to negative 2 times 3x squared plus 1 to the negative 3 times 6x plus 0. And so if you want to kind of clean that all up, it's negative 12 over 3x squared plus 1 to the third. So that's our first example, and we'll jump into our second now. This one will be maybe a little bit easier to see how the chain rules at work. We start with sine cubed of x. And this we can think of as h of x equals f of g of x, where f of x is equal to x cubed and g of x is equal to sine of x. In other words, we have sine of x being cubed because of this right here. So h prime of x will equal, well, first we deal with that cubed bit, so 3 times the sine of x squared. So again, that's dealing with this outer function of the x cubed, or the, sine cubed. Then we do the derivative of this inner piece, which is going to be cosine of x. So if I want to write that maybe a little bit cleaner or closer to what we had before, that's going to be 3 sine squared x cosine of x. So that's the derivative there. And we'll do one more example. Derivative of sine of x, sine to the 6th x cubed. And this one you'll notice is a bit more complex because this is kind of like, I'm going to use some different variables here, j of k of L of x, because we've got 3 functions nested here. So j of x is equal to x to the 6th, k of x is equal to sine of x, and L of x is equal to x cubed. Now, when you're solving problems, say on the AP test, you don't need to write all of this out, but it might be useful when you're first starting or thinking through it to write these out. Another way that you might consider writing it is something like this. sine of x cubed to the 6th. So you can kind of see those layers where the outermost part is the x to the 6th, then you've got a sine function inside that, and then you've got an x cubed inside that. Whatever works for you is going to be great, but I'm just kind of showing you some examples. So if we take the derivative first, we need to deal with the outer part, that 6 exponent. So we'll get 6 sine of x cubed. Again, we don't touch anything inside of the nested functions. Then we multiply by the derivative of the inner function, which is going to be cosine of x cubed. Again, don't touch anything inside. And then lastly, the derivative of this inner part, x cubed, 3x squared. And so if we clean that up a little bit, we get 18x squared sine to the 5th x cubed cosine x cubed. And that's our derivative. So that's a couple examples. The big thing here is just practicing and being able to quickly on inspection break something down and figure out which functions are nested within other functions. That's going to be what you need the most practice on typically in this unit. It's just being able to look at a function and see how it's constructed. So in class, if you're not quite sure, ask or try and rewrite the function and just get that practice going. So that, though, is the chain rule.